Here we're going to talk about control volumes once again, but we're going to focus on devices. The first device is a nozzle. A nozzle is basically a constriction where we have, for instance, it's a pipe which it has a constriction. We have its velocity at the entrance, and then the situation here is that this increases the speed, so the velocity at the exit is very large compared to the velocity at the entrance. And well, it does not need work, it does not need heat, or we can say that the heat might be negligible. The change in kinetic in potential energy is zero. So what is going to happen? The first law here is going to express as enthalpy at the entrance plus 1/2 of mass velocity 1 to the square at the entrance equals the same. The diffuser is basically the same. The only difference between the nozzle and the diffuser is that instead of having a constriction, well, we have the other way around. So the kinetic energy or the speed is going to decrease at the exit. So this speeds down the fluid that is entering the diffuser. The area at the exit is larger than the area at the entrance. So if we take into account that there is no heat loss, well, it's going to be basically the same first law. A compressor, for instance, is a device that increases the gas pressure by external work. So we usually have to plug it into the electricity. We have a shaft that is doing external job or external work, and there is a fluid that is going inside, and then a fluid that goes outwards. So the enthalpic level at the outside is larger than the enthalpic level at the inwards. And the first law, for instance, well, we can have heat losses as well from this device or whatever. And the first law is the same first law that was stated for control volumes in a previous video. It is very important to understand that the compressor works only with gases. No liquids should be in the compressor. In order to increase the pressure of a liquid, we use pumps. A turbine will use, for instance, a gas in order to produce power. Turbines are very used, for instance, in electricity generation and in airplanes, also in aerospace, and the situation here is that we are producing shaft work. We introduce a high enthalpic level of gas, and we're going to exhaust this gas in order to generate this power. So the main output here is the power that is going to be generated by the turbine. The first law is exactly the same as the one we saw at the other video, at the previous video. A throttling valve, for instance, is a device that we usually use in pipes in order to regulate flow. But for instance, if we have some ideal gas that is entering the throttling valve or any other fluid, what is going to happen there is that the enthalpy is going to remain constant. So So this is called an isenthalpic device. And the situation there, for instance, is that the internal energy can be converted into flow of energy. So for instance, what is going to happen here is that the internal energy is going to decrease, since enthalpy is going to be, for instance, the same. The only situation is that the pressure times volume has to increase. And if there is an ideal gas, for instance, the temperature will remain the same, since the enthalpy is the same. But that only applies in an ideal gas. In a heat exchanger, we have two fluids that are exchanging only heat. So, for instance, they are separated, they are not mixing. What is going to happen is that if we have a fluid that has more enthalpic level, which is, for instance, the red one, it's going to input an amount of heat into the one that is in a lower state of enthalpy, which is the blue one. And the blue one will increase its temperature, while the red one, which has more enthalpic level at the beginning, is going to decrease its temperature, because heat is being provided from one to another. There is no external work here, it's only heat exchanger.